Hello everyone. In our last video, we have seen some basic concepts of graph theory. Like we had discussion about graph. We defined what is the meaning of graph and what is the meaning of null graph, followed by trivial graph. And we have seen what type of edges we call it is a parallel edges. And when we say graph is multi-graph, and what is the meaning of simple graph and what are the different types of different properties of simple graph, right? I hope you remembered all those properties. Those properties are useful for practicing problems. Okay. Now, and also we have already seen one more theorem that is called sum degrees theorem. Okay, sum degrees of vertices theorem. Now, in this video, I'm going to discuss degree sequence and what is the meaning of graphical sequence and how to use Havel-Acme result in order to decide whether the given degree sequence represents simple graph or not. Okay. So first, I will explain what is the meaning of degree sequence. Degree sequence is nothing but just write degree of all vertices in the either in the increasing order or in the decreasing order. Repeating once again. So writing degree of each and every vertex either in the increasing order or in the decreasing order, that is called degree sequence. Okay. For example, if I take simple example like I have one graph with 5 vertices. Just I'm taking a graph 5 vertices. Okay. Like this. Just in as a given graph, we have 5 vertices like A, B, C, D, E. Here. And what is the degree of A? Degree of A obviously it is 3. Degree of A is 3. Degree of B 2. Let me write the degree also. Degree of A is equals to 3. Degree of B is equals to 3 because 3 edges are there, right? 3 edges. And degree of C that equals to 2. And degree of E 1, 2, 3, 4. So 4. And degree of B that equals to 2. Right? If you could arrange all these degrees in the form of either increasing order or decreasing order, that sequence is called degree sequence. Suppose if I start from degree of A, which is 4, and then degree of A, which is 3, degree of B, 3, and degree of C, which is 2, and then 2. This is called degree sequence. Okay. Arranging the given degrees of all vertices in a decreasing order or in increasing order is called degree sequence. So generally, in most of the textbook they mentioned is a decreasing order. Therefore, we can say it is a decreasing order. So degree of E is equals to 4. Check here, degree of E is equal to 4 or not? Yes. Degree of degree of A is equal to 3. So clearly degree of A is equal to 3. And degree of B is 3. Right? And degree of C and D are 2 only. Right? Therefore, the representing degree sequence in the increasing order and the decreasing order is called degree sequence. Then what is the meaning of graphical sequence now? What is the meaning of graphical sequence? Suppose if the degree sequence, if the given degree sequence represents simple graph, that sequence is called graphical sequence. Okay? If the given degree sequence represents simple graph, that sequence is called graphical sequence. Right? But what is the meaning of simple graph? No parallel edges and no self-loop exist in the simple graph. Remember that. Okay. Let me discuss what kind of problem they ask in the gate paper. Now see which of the following degree sequence is or are graphical sequences. Means they're asking whether the following degree sequence representing simple graph or not. Okay. So first I want to write the definition also, otherwise you may not understand. What is the meaning of graphical sequence? Graphical sequence is nothing but the given degree sequence must form simple graph. Okay. So given degree sequence must form simple graph. The given degree sequence forms a simple graph. Forms a simple graph. Here, the given degree sequence forms a simple graph. Then only we can say that degree sequence is graphical sequence. Okay. Graphical sequence. Suppose if it is not visible, I can write in a separate line, which is simple graph. Correct? Let me see. Let me see which of the following degree sequences represents a simple graph. First, verify that in the decreasing order or not. Yes. First example, 4, 2, 2, 1, 1. It is a decreasing order sequence. Therefore, it is called degree sequence. Okay. First one is degree sequence. But I want to verify is that degree sequence forms a simple graph or not. Is it clear? Is a sequence, degree sequence forms a simple graph or not? Observe how many ways we can do whether the given degree sequence is simple graph or not. There are three methods are available. Okay. There are three methods are available. The first method, method number one, by using properties of simple graph. By using properties of simple graph, by using properties of simple graph, we can verify whether the sequence is given degree sequence is graph sequence or not. Okay, that is method number one. And the method number two, by plotting vertices, by plotting vertices with the help of given degrees, with the given degree sequences. Okay, means we can draw the graph by plotting vertices with the help of given degree sequences, and then we can verify whether it is forming simple graph or not. Okay, this is a method number two. And the third method is method number three, by using Havel-Hakame result, by using Havel-Hakame result, we can verify given degree sequence is forming simple graph or not. Right? First, you must understand what is the meaning of graphical sequence. If the given degree sequence forms a simple graph, then only the degree sequence is called graphical sequence. Okay. In order to prove that whether the given degree sequence is graphical or not, we have three methods are available. One is by using properties of simple graph. Another method is by drawing graph with the help of degree sequences. And the third one is Havel-Hakame result. Okay. So first I'll explain method one and method two. Later I will discuss Havel-Hakame result. Okay. Now look at first one. Which of the following degree sequence is our graphical sequence? Means which of the following degree sequence are forming simple graph? Okay. What are the properties we are having for discussing whether the degree sequence is simple graph or not? Okay, I'll list out the properties of simple graph once again here. Properties of simple graph. The first property you have to remember, maximum degree of any vertex, maximum degree of any vertex is n minus 1, where n is equals to number of vertices, n equal number of vertices. It's the first property. So why maximum degree of any vertex is n minus 1? The reason is if any vertex is having degree more than n minus 1, then definitely there should occur some parallel edges or self loops. Then it is not a simple graph, right? So for example, let me take simple example to get clear idea. So this is a simple graph, right? This is simple graph. If you take maximum degree, only three. Maximum degree is only three. In this case, n is equals to number of vertices are four. Four vertices. Four vertices. And max degree of any vertex. Max degree of any vertex in this problem is equals to n minus 1, that equals to 4 minus 1, which is equal to 3. Maximum 3 only. Because if you take one more edge, definitely it is taking parallel edges. Parallel edges. For example, I want to add one more edge like this. One more edge. Obviously, there are parallel edges occurs, right? Parallel edges occurs means obviously it is not a simple graph. Therefore, in a simple graph, maximum number of edges must be max number of edges for any vertex or max degree of any vertex must be n minus 1. Okay, max degree of any vertex must be n minus 1. That's first property we can use. And the second property, sum of degrees of all vertices is equals to 2 into total number of edges. That is equals to even number. Of course, it is not only applicable for simple graph. Remember, it is applicable for any graph, but I can also use this for simple graph. Okay, it is applicable. It is applicable for any graph. For any graph. Not only for simple graph. For any graph, it is applicable. Since it is applicable for any graph, so I can also apply this property for simple graph, right? That is the reason I have written this point. Okay. The third point, number of odd degree vertices. In the last video, we have already seen what is the meaning of odd degree vertices. If any vertex having degrees odd, that is called odd degree vertex. Number of odd degree vertices must be even. Must be even. Then only we can say that sum of degrees of all vertices must be equal to 2 into number of edges or even number. Okay. This point also we covered in the last video. So, and the fourth one, maximum number of edges. Maximum number of edges in a simple graph. A simple graph of n vertices is equals to n into n minus 1 by 2. This proof already gave in the last video. Please watch previous video before watching this video. Okay? These are most important 4 properties in order to answer the question. Okay, let me verify. Okay, these properties are